handout with the? I'm gonna start off doing the one that we ended yesterday with, because I looked at the answer afterwards, and maybe I was in too much of a rush at the end of the period. But it looks like we did something wrong. So just with a little bit more time, we'll start off on this one. Then there's one more example on this set of slides to go over, and then we have an activity that we'll finish the class with. That'll be like somewhat, because really all we're doing today is a composition, which just means more than one, of things that we've already done. So it's kind of like a review. Okay? And then on Monday, I told you that you would have a choice whether we'll have a teacher-led review going on here, and then either, depending on how many kids choose whatever they choose, either somewhere else in the room or somewhere else altogether, we'll have if you want to work on the assignment, let's do Monday. That's the next assignment, let's do on Monday. And then you can pick where you want to go. So let's try this one more time. I was checking the answer. We did something wrong yesterday. I think I was in too much of a rush at the end or something. So
I didn't make
let's try again. So okay, we started this already. We see the pre-image over there. Let's start off with K. Let's do K prime nice and slow. The first thing they want us to do is to rotate 180 degrees about the origin. So what's the rule for
negative x, y?
Should be no. The rotation should be negative x, negative y. We should be changing both, keeping them in the same order, but changing them both. So that means K prime after the first step would be -4 and +1. Okay. Then the last thing they want us to do is a y-axis reflection. On a y-axis reflection, we leave everything where it's at, but change the sign of the x.
4, 1.
See, yeah, and you know what? That's what we got yesterday, but then they're not saying that.
Should we do the rules for each? Like, go ahead and do the 180.
Let's just finish this. Let's just finish this, and then we'll go compare it with their answer and see. Maybe I was just reading the answer wrong. Maybe I was reading it wrong. We did get it right. I looked at it quickly, and it looked to me like I remember that for us it ended up in the first quadrant over here on the top right, and then when I was looking at it, it looked like on the answer it ended up on the top left. But maybe I was reading the answer wrong. Maybe we did do it right. Let's just go over it again. Who cares? It's free work. So all right. So this is 4-1, right? We all agree 4-1 after both transformations. Okay. So let's do the same thing then for L. We start off at 5, -2, but then we're supposed to switch both signs. So that's -5, +2. And then just switch the sign back for the x. So that's 5, 2. Yeah, I think that's what we got yesterday too. Yeah. And then for M, switch both signs, which is -1, +4. But then switch the sign of the x for the second transformation. Did I go too fast there? These are all things we've done before. None of this is new. So we go with 4-1, which is I'll just write K prime. K prime 5-2. That is L prime, and then 1-4 up here is M prime. Yeah, that's the same thing we got yesterday.
And that's saying that's not right?
I might have read it wrong. Cause now I see yesterday I wasn't confident in myself because I felt like we were rushing at the end. So when I saw the answer, I just assumed that maybe we did it wrong. But before I reveal the answer, we're on agreement that we did it right, correct? All right. So let's see what the answer says. Maybe I just read it wrong. Okay, so
that's the green.
No, yeah, we did it right. Maybe that's what it was. I assumed it was in green, but it looks like green is actually the first step. So what you see over here, these points in green, I guess those should have been then what we got after the first transformation. Let's see if that's right. Did we have these here? -4-1, -5-2. Okay, so then I was just reading it wrong. We did do it right. Yeah, those were the ones up top. Okay, so that's good. So like just focus focus here on the red, right? Everybody sees the red. Now let's go over here, also red. We got the same thing. They do use better notation. I guess I don't know. I don't know if every book does it this way, but I guess fine. We should do it also. Do you see the difference between the green and the red as far as the notation goes? What's different? They have two apostrophes. I guess yeah, that just shows that we underwent two different transformations. I wouldn't hold that against you, but just so you understand why there's two. That just means that's the second one. I left it on the first slide as just a single one. I don't know. I'm not, like, we're gonna do an activity today where we have like 8 transformations to do. I'm not gonna write 8 apostrophes on every single one. But, before you.
No, no.
You getting ready?
No, I'm like lazy.
Oh, alright. There you go. There's another one. JKL, which you can, it's hard to see, but because it's in blue. Here, I'll make that one in red. So you see it better. And they give us those vertices, and they want us to reflect across the Y. And that's the same thing. We're just doing it backwards.
They're just doing it the opposite. Yeah, they're doing Y reflection first.
Should that even make a difference? No, I don't think it shouldn't. Because if we reflect across, and yeah, it's gonna end up in the first quadrant anyways. Will the fact that I don't know, maybe let's do it anyways. Maybe the fact that we have a zero coordinate, maybe that's something that you're not understanding now that maybe you'll understand better. So we're gonna go backwards though. We're gonna do the y-axis reflection first. So there we just change the sign of. Let's just do J prime. We just change the sign of the x. So we start off at -1, -2, and then finally, you know what they did? They did the double prime. But once you do the 180-degree rotation, 1, 2, yeah. Okay, K prime. Change the sign of the x first, so -4, -2, and then Jamal for the 180 rotation. What do we end up with? Just 4, 2. And then finally, if there's any like purpose in doing this one, it would be here, because at least we can check out what happens with the 0. That should be we change the sign. It should be -3. And then when we change both signs, we go back to 3, but 0 stays the same. So in the end, what ended up happening to L? It stayed exactly where it's at. L kept the same point. So when I plot these, L stays where it's at. J ends up at 1, 2. And then K ends up at 4, 2 up here. Remember that these are rigid motions, so those preserve size and shape.
Wait, so with that -3 on L,
Okay, well the first thing we did was a y-axis reflection, which we started off at 3, 0, so we just changed the sign of the x to -3, but 0 doesn't have a sign. So I mean, we're not supposed to change it anyways, but on the second step, when we do the 180 rotation, we are supposed to change it, but 0 has no sign. So we just the only thing that we ended up going right back to the 3 for the x. We can check our work, and they got the same thing we did. That's pretty much it, because the last couple slides, you can categorize this under stuff that you'll learn, but you'll never need again for the rest of your life. It's not too important. You can write it in your notebook if you want. Joseph, it's not that bad, though. You can still learn it. You can say you learned something. It's kind of a rule. Like, the reason why I'm saying you won't need it is it's not going to show up on the test. You don't have to know this specific thing, but hey, we're still learning anyways. That any translation or a rotation, which we know already, can be mimicked. Like we can get the same result by doing a double reflection. Depending on where I place my axis, I can get the same result as a slide or a turn by getting a shape and flipping it twice. How? You don't have to write all this. I'll give you the important information here. Two reflections with parallel lines, that's a translation. If you do a double reflection along axes that are parallel, you see an image of this here. They give you a picture of it. If both axes are parallel and I do a flip and then another flip right afterwards, what does it end up looking like? A slide. It just looks like it's slid across. Won't be on the test, but it's just free information. You okay? You're doing a vision test?
That might be a good, like, EOC type of question, though. Something you might see something like that.
Maybe,
on a
maybe,
standardized test, possibly.
maybe. Okay, and then the last thing to know is that if I have two reflections across intersecting lines, they don't necessarily have to be like perpendicular, just intersecting lines, that would be equivalent to a rotation. Here they show you an example of this, where they got this blue. In blue we had the pre-image. They flipped it once over an axis, and then they flipped it again over another axis that happened to cross the first axis. And in the end, the final result is that it looks like, if they wouldn't have drawn the axis there, and I asked you what type of rotation occurred, what type of transformation occurred, you would have just said, oh, that looks like a rotation. Stefan, any reactions? You got the poker face on.
Questions?
You writing anything down? No, just paying attention. Okay. Well, then let's give you something to write down then. Let's do this activity. Let's put everything together as one.
This might be good if they've got like colored pencils and you do like each one and then different.
I don't know how many of them have colored pencils, but yeah, sure.
If you want to see your different ones. Brian did talk to you about the drumline thing.
Yes.
Came in here.
Yeah, he came in. I told him he can watch some of the video.
Yeah, and I'll give him this.
I'm guessing you don't have colored pencils, but at least you have a pencil. So maybe I would try to draw this stuff lightly on here, and then once we finish, then we'll darken it up.
Can you pin?
No, I'm not gonna collect whatever you like. So what we see here is a quadrilateral. It actually looks like it's a trapezoid. And it's hard to see. Maybe you might want to write it in. That's called ABCD. Up on the top left is A, top right is B, bottom right is C, bottom left is D. And they want us to do, well, it looks like 8 transformations, but it's really 7, because the last one is just a shaded. And this will be just one big review of every transformation. Sure. For translations, we can just count there are no dilations here, so that's good. These are all, let's ask you for the second day in a row. What do you call the transformations that do not change size and shape? It's not a dilation yet, you're right. Yeah, I just said that. You're right about that. It's not dilation. And I'm not even asking you to name the ones. I just want to know, like, what's the name that we gave you. You can be one or, there's two different ways you can name them. The types of transformations. There's obviously three of them. She just said dilations isn't one of them, so there's obviously three of them. But what are the different ways that we can categorize them? One of the names was just on the board. The other one was when we first did transformations. Jaden? Yeah, an isometry up. That's one way. Thank you, Jaden. And what was the other one? What did we call all three? Back when the transformations were first introduced, the three transformations that do not change size or shape. So, wow, Josh, man, you're on point today. Okay, so let's see. The first transformation here, they want us to translate this 13 units to the right. What would be the best way to go about doing that? Just count. Just count. Just count. But actually, you know what, Stefan, you gave me a good idea. Since we struggled with this, and since we're not going to have a reference sheet for the test, I can't give you a reference sheet for the test. Just for fun, let's write this in what they called arrow notation. So what would be that rule for number one? I'm gonna get every x and y, and if I'm gonna move them to the right, it would be x plus 13, and the y just stays the same. Just for fun. They're not asking us to do that, but let's do it anyways. So let's count 13 units. Now, see, if you're trying to save yourself time, you want to be smart about this. How many times should I have to count to 13? I'm not looking forward to counting to 13. Well, just once, because then every other point, since we know that we're not changing size and shape, we can let every other point just fall in line based on relativity. Like, so let's start with A. Ready? So A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I'm going to put the A right there for now. It said, yes, could I go back and count 13 units to the right on every single one? Absolutely. But if I know that B was supposed to be 3 units below, I can just put another point. Sorry, that's D. I can't even read that. Sorry, that's a D. I can just put another point 3 units below. If I know that B was 3 units to the right, I can put another point 3 units to the right. If I know that C was 3 below and 2 to the right of that one, I didn't go far enough. Yeah, I didn't go far enough. So after transformation number 1, that's where we ended up at. You know what? I don't think you have to write light. If you have pencil, you can just do it normal, because at the end they're going to ask us to shade in the final result. So, okay, let's change up the colors. Number 2 says reflected over the dotted line. There was one just like this on the quiz where at least they're not asking you to write the rule, because for reflections we only really have rules for the axes, and for y equals x and x equals y, and we don't really want to have to subtract or add before that. So we won't worry about writing the rule, but let's at least know how to perform the reflection. This bottom point here, which is what D ended up becoming, how far is it away from the dotted line? 2 units. So let's put it 2 units. So let's put it 2 units below the dotted line. Let's do this. Let's go A, B, C, D. And hopefully it doesn't look too cluttered. So this is gonna be D right now. The C, even though that looks like a G, but it's a C. How far is that from the dotted line?
5.
0. That's a C there. How far? C.
2.
Yeah. So I'm gonna go 2 below also. Now, because reflections also preserve size and shape, technically I could do this just the same way I did the first one by plotting all the points relative to each other. But I think with reflections, maybe you're a little more likely to make a mistake because you have to account for the flip. It's up to you. Just make sure, like when you put A and B, after you flip, A and B better end up below C and D. So, like, look, how far is A from the dotted line? If you were to count for A, how far is A from? You can also look at your paper because you have this written down there. How many units? 5. So you can count 5 units below the dotted line. Or look, I mean, I guess if you wanted to, you could say, okay, if A was 3 units above D, A is going to be 3 units below D. Just be careful. Make sure you put it below. And then just make sure that B is 3 units to the right. So far we got step 1 taken care of. Kyla, what do they want us to do next?
To translate 4 units down.
Okay, so let's get every point now, and let's go 4 units down. Just for fun, not because they're asking us to do it, but because we know how to do it. How would we write that as in coordinate notation? No, 4 units down. 4 units down. Skylar? How would I write that rule on number 3 in arrow notation? Coordinate notation. I want to go 4 units down. I did the first half for you. X comma Y. Andrew, do you know?
Wait.
That would be reflected in the line.
At
this point, you're going to rotate 90 degrees counterclockwise, which did you get?
You know? I want to slide down 4. Alvin, do you know? Nah.
Wait, hold on a second, sir.
Wait, what? Slide down 4?
Yeah.
Subtract 4.
From where? No.
Y.
From Y. Thank you. The X stays the same. Y minus 4. Should be no reference you needed.
Wait, did you say 4 left?
X minus 4. Actually, I think you just said minus 4. You didn't even tell me what she said. X minus 4. You just said minus 4. Gotta be specific. Y minus 4. Y minus 4. Y minus 4. Y minus 4. Not X minus 4. Y minus 4. So we'll go 1, 2, 3, 4. Which we put here. Down 4. Down 4. And down 4. So I'm color coding this for you. This is D, this is C, this is B, and this is A so far. All right, what do they want us to do next? Okay. Yes, we can do this by counting. We just the same way we reflected on step 2, we can do it by counting. But since we do have a rule for y-axis reflections, why don't we just go ahead and follow the rule? Let's just challenge ourselves a little bit more, and let's follow that rule. What's the rule for y-axis reflections? Here, let me put it this way. I think I can do this without getting into too much trouble. We won't be able to use the reference sheet, but it would be like very, 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 very much in your favor in order to memorize that reference sheet. So if you can like really study these rules and know them, you're gonna get a lot of questions right just on that, just by knowing the rules. So again, can you tell me what's the rule for a y-axis reflection? Okay, just, I would really just tell me negative x comma y. So let's tell me what a is going to become right now. Okay, we don't have to do this. We left off on green. And hey, look, I can just count. A is 4 units away, so I can put it 4 units away over here on the left. If all they're asking you to do is draw, it's fine. You don't have to do this, but I'm just trying to give you some more practice. So right now, A in green is at 4, 2. If I change the sign of the x, where am I going to end up at? If currently A is at 4, 2, negative 4, 2, good. And then if B is currently at 7, 2, negative 7, 2, good. C is at 9, 5, negative 9, 5. Stefan, you're fantastic, good job. And then finally D is at 4, 5, so that'll be at negative 4, 5. So negative 4, 2. I'm not even telling you that this is the best way to do it. I'm just trying to change things up to give you a better understanding. One, 2, 3, 4, 5, 6, 7, 8, 9. 5. Let's see. And then D is gonna be at negative 4. Doing it this way could actually save you if you're doing it like this using math. This could actually maybe keep you from making a mistake. It'll make sure that you have the points in the correct order. Ooh, nope. Josh, question?
I wanted to check.
Oh, I can check it.
What even matters to the
Is he flirting with you again?
Asking.
That is what
Okay. Joseph, if you're bummed out because we haven't done a rotation yet, you're in luck. Here comes a rotation. And the nice thing is, this is around the origin, so we have a rule for that. Another nice thing, hint, 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 is to pay attention to the direction. This is a 90-degree counterclockwise, which is good because that's what we have rules for. But just theoretically, if this were to say clockwise instead of counterclockwise, what is a 90-degree clockwise rotation? Yes, what is a 90-degree clockwise rotation the same as? If that's what they were asking us. I'm going to do counterclockwise, but if it asks for clockwise, what is a 90-degree clockwise the same as? Say it again? 270, yeah. 270, is that what you said? Yeah, 270 counterclockwise, yeah. So definitely with rotations, you're going to want to follow the rules. I'm not going to try to attempt a rotation by counting boxes or anything. So luckily I have all of these points written here. First, let's write the rule. What's the rule for a 90-degree? Jamal, do you know? Very good. Yeah, you do. You do switch the x and the y. That's excellent. And then y is negative. Wow. And I thought you were drifting away. I thought you weren't paying attention. Good job. Wow.
But I'll make it. It's okay.
You got Joseph's attention, so that's good. All right, so then let's do, let's check out the A. But if I need to switch the X and the Y and then change the sign of whatever coordinate ends up coming first, what's A gonna look like? If I flip them and then change the sign of the one that ends up in the front.
-2.
Yeah, good. -2, -4.
I know it's a good job.
He's on fire. Call him Butter because he's on a roll.
I've never heard that.
No.
Guys, my suggestion for these,
Guys,
y'all
listen up.
listen. My suggestion for when you have to, when you have to flip the two, the X and the Y, flip them first and then change the sign. If you try to change the sign and then flip, you're gonna get yourself pretty confused. So switch your X and your Y and then figure out which one you need to change.
Ahad, how about B? What's B gonna end up at?
4.
B is at -7, 2. We just talked about flipping them and then changing the sign of the one. -2, -7. Okay. Lorenzo.
-5, -9.
Well played, sir.
Are you good?
Still, not funny joke. You're still on there?
And then Joseph Dennis. How about the last one?
You flip the,
Just tell me what you get.
oh, 5.
We're at -4, 5.
Oh,
If you can't read my handwriting. And if we flip it and change the sign of the one that ends up in the front.
that
D. I want to do D like in Dennis.
one. 5.
Flip them, but then change the sign of the one that ends up in the front. -4. -4, -5, -4. Okay, so let's throw this up there. -2, -4. That ends up being A prime. -2, -7 is B prime. So then -5, -9. That would be C prime. And then -5, -4. That would be D prime. So we're getting there. Two more steps to go. So let's do another y-axis reflection. This will be now the second time that we reflect over the y-axis. What's the rule for that? I think I'm running out of colors. Let's go with black then. What's the rule for the second time for a y-axis reflection? Say it again. Good, thank you. You, sir, are a gentleman and a scholar. Charles, you're hiding today. So do that for me. We left off in this, it's supposed to be orange, but it looks like, I don't know, like a yellow or something. But, so we left off right above. Let's just change the sign of the X.
Okay, so just 2.
Okay, good.
And just keep the X. I'm gonna keep the X.
Keep the
change
Y.
the X,
Keep the Y at -4. Do the next. Do the whole row, Charles. Come on.
Okay.
So instead of -2, -7.
So +2 and -7.
Okay. Then. Come on. No. All right. Woosah. Okay. C, Charles, is gonna be?
That's gonna be +5 and -4 and then.
No, it's a 9.
Oh, -9.
That's fine. We'll blame my handwriting on that one. And then finally,
That would be +3.
that's a 5.
Oh, that's
So
a
+5.
five.
You don't have it written on your paper?
I do, but I can't. I thought it was a 3 on the phone.
Your handwriting is worse than mine? 5-4. So we got a 2 and a -4. That's what A prime turns into. B prime is a 2 with a -7. C prime is a 5 with a -9. 1, 2, 3, 4, 5. And then D is 5-4. And only one step left to go. Uh-oh. What are we scared of here?
That's a good question.
I ain't scared of nothing.
Number 7, what do y'all notice about number 7?
Number 7, rotate around.
It's a rotation, which we've done before. And I mean, really, everything about number 7 we've done before. But why do you think I'm clearing out all this space here? Why am I gonna need this space? Jaden, you wanna help us so we can get through this? What are we Okay, if you were given a rotation on the test on Tuesday, what are you really hoping that rotation is around? The origin. Now, most people would say the origin. What are we rotating on for number 7? Point D. Point D is not on the origin right now. So we got to go do a rotation around D. So where is D at right now? Sorry that I erased it. You should have it on your paper. So is it at 5, -4?
Yes.
Okay, so let's do this around 5, -4. Here's that SRA that Ms. Lamb was talking about. We want to get each point, and we're going to subtract the point of rotation, do the rule, and then add it back. So let's go with A first. Right now, A is at 2, -4, right? So the X is 2. I'm going to subtract the X of the center. What's the X of the center? What is the X of the center? Yes, Jamal. I literally wrote it on the board. Didn't even say that. It's on the board. It's 5. So 2 - 5. Then the y for the a we left off is at -4. And we're going to subtract the y from the center. What's a minus -4 the same as? As the same as plus. So plus 4. So right now we're going to be at -3, 0. That's after the subtraction part. Now comes the rule. Ryan Ames. What's the rule for a 180-degree rotation? This will be the third time we do this because we did it on the other slides twice.
To change the sign.
Change both signs. Leave them where they're at. Change both signs. 0 doesn't have a sign, so just 3, 0. And then finally, what's the last part of this? We subtracted. We did the rule. Now the last part is to add. So we're gonna do 3 plus 5, and then 0 plus -4, which is the same as 0 minus 4. So when all is said and done, a is at 8, comma -4. So let's go with 1, 2, 3, 4, 5, 6, 7, 8, and then down to -4. That's 8 prime. Okay, so now let's do B. B is starting off at 2, -7. So I get the 2 and I'm going to subtract the 5 first. I'm going to get the -7 and subtract the -4. That's the same as adding 4. So I get -3 again. But then here I also get -3. That's subtraction. Now let's do the rule. What's the rule for a 180?
Negative x, negative y.
Change both signs, so we end up at 3, 3. Then at the end we add it back. So 3 plus 5, -4 plus 3. So we end up with 8 and -1. So 1, 2, 3, 4, 5, 6, 7, 8. So this is B prime. Now, something that you may not know. When your point of rotation is on, how can I say this? Let me not even say on the shape. Let's say when your point of rotation is one of the points, one of the vertices on the polygon, that one's not going to move. So, I mean, if we have time and you want, I'll go ahead and do D, but I can tell you that D is going to stay right where it's at. Nothing's going to happen to D. If I were to get this with the tools up here and it lets me do it, and I were to say, hey, I'm going to rotate around D, D's not going to go anywhere. The trapezoid is going to go like around the world, but D's not going to go anywhere. So really the only one I have left to find is C. Yeah, you know what? I'll make sure I squeeze it in. I want to show you D anyways, because you're gonna see Y at least that it's gonna stay in the same spot. So, but let's just do C first. Where's C starting off at? Is that 5? Is it -9? Yeah, 5 -9. So 5 minus 5, and then -9 plus 4. So C prime is gonna be at 0, -5. After the subtraction part. Oof. Carly, what's the rule for a 180 rotation? Go ahead, Alvin. Yeah, this is the third time we do it in the last 5 minutes. Yes, change both signs. And then finally at the end, add it back. So 0 plus 5, -4 plus 5. So we end up with 5, 1. 5 and positive 1. So 1, 2, 3, 4, 5 and positive 1. So like I could already, if I wanted to finish, actually this is sequence. If I wanted to finish what I was being asked to do, and that's shade in my finished product. That's what it would end up looking like. But let's explore why D stays in the same spot. D is the point of rotation. So I know D is at 5, negative 4, right? That's where we started off at. What is anything minus itself? 0. So 5 minus 5, negative 4 plus 4. So we're at 0, 0. And then when we change signs, nothing changes at all. It stays at 0, 0. And then finally at the end, when we add it back, 0 plus 5 and 0 minus 4, we end up going back right to where we started, which was 5, negative 4. That's why D doesn't change. No questions? All right. You know what? Here, I'm going to do this also before you leave.